So we're here to talk through this Pentominous borders puzzle by Mark Sweep. It's his first guest construction on the site, and we hope you have fun with it. At least the puzzle suggesting you have fun with it. But as a Saturday puzzle, it's fairly tricky. In working through the solve, the first thing I'm going to do is just turn off the number part of the interface. So I'm not going to write letters in, but I will draw lines for unique Pentominous shapes, and I will draw edges as they come in. One of the things that I actually found in this puzzle is my first route through the puzzle was very fast because I ignored some options. For instance, for this U in the upper right, I saw quickly that these U's are different shapes, the F's are different shapes, the N's are different shapes, but I ignored the fact that like this was an option for the U. The U actually has 4 options. It can be this, 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 or this one that's coming down. And if you miss any of these choices and it's a choice that's not in the solution, your solve will be much faster. One of the things in sweeping through those 4 choices, though, that will help you quite quickly is one of them can be ruled out immediately. This U to the left wraps around the F entirely, but where the F will normally need a 3x3 bounding box, it can start sort of filling some space, but where it's going to need to take another edge, it's going to go off the grid. And so that option is no good. All of the U's that remain take this cell, and if you ignore the fact that this was a potential U, you could also take the next deduction, which got me started quickly. So I'm going to look at why we can ignore that option, at least as at this stage in the grid. And one of the reasons we can ignore it is in part it's going to bring this U near to this U, which is going to quickly force the remaining options for this U. And this U at the start of the puzzle actually has 6 choices. It can come left and around, right and around. It can split left and right but come up, and it can split left and right and go down, left and around, going downwards, and right and around going downwards, all these sort of routes. One of the things is after we put in this U, we've now eliminated all but 2 of those choices, and these 2 choices all have reasons they fail. The U coming up is going to force this F to touch that F. In part, it's going to have to come and take these cells. It could be this F or it could be this F, but both of those F's have the F's touching. And a similar set of reasons will help with this N. This N coming across now means this N has to be horizontal, and it runs into the Y or it runs into the U, whichever shape it takes. And so all of that is one way to say that start of the puzzle where there are 4 potential U's. This U that wraps around the F is no good. The U that wraps around the N is no good. These 3 cells are taken by any of the U's that are used, and there's still 2 options for it. We can't do more than that, but this is one way to start the puzzle. A different way to start is to actually consider all the shapes that these 2 ends can take, and here again, in one of my earlier videos, I actually did this right in my first solve, but not in one of my earlier tries of filming this video. I had some funny logic here where I ignored 2 of the 6 options that are possible for this N. So this N has 4 roots at the start of the puzzle where it could be a vertical N shape. It could have 2 coming up this way or coming up this way. Obviously, we've now marked some with the U, so we've eliminated some of those choices. But at the start, these upward roots would always force the U shape, whichever way it goes, to encapsulate the F. And so you can eliminate the 2 that are going up and say that there are these 2 coming down, but you have to not ignore that there are actually 2 horizontal groups for this N. This one that quickly eliminates, and this one, which now that we've marked this U shape up here, also eliminates because it isolates the cell. But until you're doing this strictly rigorously, this space where this N has to come down is probably all you can do until you get this U over to here. That the U doesn't take the cell and that the N doesn't take the cell means that this comes straight down, and we now actually force the first pentomino in the grid, this N. But depending on how you looked at the U options and the N options at the start, this is easy to find or hard to find. And certainly if you look at all of the choices, the 6 that start for the N and the 4 that start for the U, it takes a little bit of visualization to see what the eliminations are. First this edge coming to the right and then the rest. So with those in the grid, though, we have a fair bit we can now do to make headway. Particularly this lower right corner is now a place where counting is going to be quite useful. We've got 10, 12, 14 cells out to 15. You always want to break out the grid when somewhat isolated to multiples of 5. And so we will mark in these cells to start that. We now can also think about, is this starting shape of 3 cells coming down connected to the Y or not? And you should be able to quickly visualize that it has to be part of the Y. I'll just show you why if it's not. If the Y is not, it's coming straight down, and you have an I to the left. This would actually be the Y shape, but this cell in the corner is isolated and no good. So this always connects to the Y. And now we have 10 cells left, and sometimes it helps to use different colors or different letters in thinking through this. These in red and these in green are different shapes, and what we want to do is think about some eliminations here. For instance, I'm trying to dodge a Y, so this cell over here, if we're part of red, will always form a Y, so it's instead part of green. And if it's part of green, then the cell in the lower right corner can no longer be reached by green. And if those four are in red, this cell now can't be reached by red. And so we have this is the way this shape splits. And it now has two options, a P with a P, which doesn't look any good, or a Y with an F, which looks fine. And so Y with F is the shape that gets into the grid. We have another new pentomino growing out of this space. Notice that this, let me go back to using red, it's a little easier to see versus green. This red and this green are different pentominoes. It can always come down, take one more, but it has to come out. This cell has to come to the left, and note that this edge has to be a firm edge. You can't come back across because the border's already drawn. We've got these four cells marked. It could be a U, it could be an L, or it could be another Y, but that Y is touching the Y that's already in there. So we can actually get that this pentomino that's coming up from red. It needs to take this cell. If it took one more cell, it would form another Y, but again, touching that Y, we've got to come across, form this shape. So F, U, or L, but not more we can do there, but a little bit further into the grid through doing this. Now if these F shapes marked, we've limited a lot of the space for this N to go, and this N at the start of the grid had a whole set of options for it. I don't actually want to try to count them right now, but there are a whole set of options for it at the start. We should now think about two things. First, in all of the options for the N, it will take this cell to the left. Notice that if it didn't take that cell, it's got to be vertical. But being vertical, it's going to have to come into this space. It would be like this intersect the Y, or this intersect the F. So it always takes this cell. And now it could still be a vertical N, or it could be a horizontal N. And by that I mean, is it a 4x2 or a 2x4 box? And if it's a vertical, it will always have this shape. And it could take one more cell or one more cell here. But notice here's an issue. There's another pentomino which is going to come up this channel, and it's going to isolate this U. And so there is no version of this N that is vertical. All the versions are horizontal. And so now we have to think about, where do we get a 4x2 box that's okay to work for this. And it can't be this 4x2 box. Let me go back to shading, because it would touch to this N. It can't be this 4x2 box because you actually can't get a horizontal section out here. And so the only 4x2 box is this one that works. And what that actually implies is that we know for sure the N takes these four cells, and I can mark this diagonal edge, and then mark actually these edges around the shape as forced parts of what we know. And that gives us a little more headway. It still doesn't like quickly break through the puzzle, but it gives us some more structure, and it also now eliminates a set of options for the U. The U used to have 6 choices. It now can't come to the left and down because it's going to avoid the N. It can't come over to here either because it's going to isolate these two cells in the grid. So it's down to just 3 choices, and those choices all wrap around the F, and 2 of them actually come over here and interact with this U. And as we said at the start, some of the more forcing conditions are where these U's come close together. We saw how this cell was bad. This cell is also fairly limiting if we use it, and the reason it's limiting is first it's going to force the U to come straight around. It's also going to force the F to come out, but note we formed this channel here, and so in forming that channel, these have to come to be the same pentomino, but the only way that's an F is to collide with the U, which is impossible. So the U cannot go to the right. The U has to come out to the left like this, and in marking that in, we actually finish our N shape. We get this F to start. And this F will again look like it's got a set of choices, a lot of choices. All Fs have a 3x3 bounding box describing them. So this is a possible box, this is a possible box, and this is a possible box. And so what we'll do is sort of go through each of them and see which are the possible ways this F can go. That bottom option has this valid shape, which looks good. The middle option is going to allow for one of these to be the corner cell, but this corner cell would touch the F, so this is always used as a corner. And so this is a valid F, this is a valid F. If it's using this top 3 by 3, this is the corner cell, this always is a long straightaway, and this is an across, which collides with the F, and so that's no good. And so what we actually know is the F always uses this space, and it could use this space or could use this space. But all of those options, actually, the 3 options, there are 3 options that are valid Fs right now. All of them take this cell. And let me go back and sort of show you just quickly these 3 roots. So there's this one, there's this one, and there's this one. But all of them take this cell. And the reason that's important to mark is because we've now isolated what look to be 8 cells in the middle here that will need to have one more pentomino growing through there. So let's get another color. And we've got 2 cells we can't necessarily say too much about, which are these, but this will always be part of the new pentomino. It can't reach all the way to the left and can't reach to the F. And it's similarly the case that these other cells down below have to be part of that new pentomino. So everything that's now in red is a start of a new shape in the grid we should think a lot about. Notice if this green from the left forms this L, then the red and blue come together and form another L. So that's no good, which means that this shape is always going to be a P pentomino. We don't know which P it is, but what we actually can say is that the F here up above always takes this cell, and in taking that cell we can mark this diagonal line off, and that gives us this edge for sure. It could take this cell or this cell to complete the F, but we've got a good start with that. And some more to now work through with this F up here, and that's because we always had 2 options with this U pentomino, this one that comes and circles in the top and forces the F to go left, and this one that has a U to the left and forces the F to go up. And so imagine if the F were forced to go left because of the U like this. This cell here is not part of the U, it's not part of the F because of the other F. We've isolated it quickly. And so as we start to get this F shape in the grid, we exactly force this U shape in the grid, which now forces this F shape in. And again, we can think about 3 by 3 bounding boxes. The F could potentially take this one, but now it's going to isolate cells like this that aren't part of another pentomino. So the bounding box is always this one. And in that shape, we need to not isolate certain cells, so we always will have to reach into this corner. And this is the only F that doesn't isolate stuff in the outside of the grid. So another placement, making slow headway, but making headway. We're now at an interesting stall point for the puzzle, and again, there are strictly 2 Fs to go. This one that goes up and this one goes down, but one of these things you'll see is, except for this junction here, there's a lot of isolation of these cells at the top. So one thing you'll sometimes do at a stage like this is start to count, and we're going to count to see where additional cells here or here will get us to a multiple of 5. And something that will help us is to actually see that this cell here, which is not part of the pentomino above, must always take these 2 cells. It could be part of a P. It looks like it could come down a little bit here, although that's going to collide with the N if it goes too far down. But this set being distinct from this green set will help us know where the give and take is. It actually limits a lot on this border. This border could get 2 more, but it can't take, it has to give back 3 if anything come in here. So in blue, I've got 9, 16, 20, 25 cells exactly. And that should tell you that if this F does not take this cell and I have 26, I'm going to have an issue because this is 25, 24, 23. I can remove 2 more, but I can't get to a multiple of 5. So the only way this partitions is for the F to use that top space. That's then this P and this T shape. And now we have an edge we can also mark in here. And now we have a whole different set of colors that will help us here. This blue pentomino that we're starting to draw may take these 2 cells or may take these 2 cells, but it's going to be completed by grabbing 2 in yellow. These shapes that are in the upper right, these greens could take these down in yellow and could take more. But what we don't have is a sort of firm count of like, does this green come up or not? And so the way I'm going to work through this is, while these in yellow aren't sure, I have a new set that's coming in red that will be either 6 or 8 total cells. Either this is a Z and I only have 6, or this is a P and I have 8, but right now where I have 6 or 8, I still need to get up to a multiple of 5. Taking all these cells, potentially with yellow, now give me a set, and this red set cannot overlap with the green set, so green will always have to take at least this extra cell. And I now have 1, 2, 3, 4, 5, 6. I need to get at least 8 shaded. I could take these in yellow as the last to get to 10, or I could take these up here also now in yellow to get to 10. And the thing that you'll want to notice, and maybe you'll get more practice at this if you actually try to construct these puzzles, is that this option for how the greens form 2 groups of 10 is a deadly pattern. It's a very symmetric shape. You'll see it's rotationally symmetric around the place my mouse is hovering now. And symmetric shapes are very hard to divide into 2 distinct pentominoes. It's actually the case you can have 2 I's, those would touch. You can have 2 Y's, those would touch, and you can also have 2 N's, but those would touch. And so this pattern is not able to be formed. And so if we're playing give and take with yellow going to red, blue, and green, this green needs to take these cells. The blue will then absolutely take these cells, and the red will take these cells. And marking in the forced edges from doing that, we get this Z, we get this P, we get this I, we get this N, we get a T. Those all look fine. We now just have this lower left part of the grid to do. And again, we're going to be dividing this into, it looks like 4 pentomino shapes. All 3 that we've marked in right now are distinct. With this one coming out of this edge, one of the things I'll sometimes do is say, what happens if I don't take a square? So let's say instead of taking this, I absolutely say do not take that. This then wraps around, and wrapping around it forms an N pentomino touching an N pentomino, so it always takes at least that cell. That now forces the shape over here to take this T, forces another pentomino to start growing out from here, which means that there's an L at the bottom. Let me go to use a different color for this, as I do sometimes before. These 3 in green can never reach this cell. These 3 in red must always take this cell. The green can only reach this cell, and we now have a P and a P, or a Y and a V, and the legitimate split is the Y and the V, different shapes. So we made our way through this whole grid, a bit of a challenging journey, at least a challenging start, to recognize that even though you have 4 options for the U and 6 options for this N, you can start to eliminate some of them quickly. Like the N can't be the N that comes over like this, because it would touch another N here. The N can't be a vertical 4x2 because it would force the U around in either of these directions and cancel off the F. So there are sort of 3 N's at the start, and if you actually look around the U's, one of these U's is quickly deleted. Another U is not so quickly, but is necessarily deleted, and in doing that, you'll carve out a space where this U is taken, but this edge exists, and this edge is not part of the N. And so just dividing out this lower right grid gets you a little bit of shape here, including this F shape, which now limits this N and this U enough that you can get how these F's interact, and then come back through counting to this upper left of the grid, and then get back to the lower left of the grid. There might have been some other routes through the puzzle, but that was my route through the puzzle. Certainly Saturday difficulty in what it did, but it highlights a whole set of pentomino steps that through shading, through lines, through even just visualizing of patterns will get you through the hardest of these puzzles, and hopefully you can take some tips and tricks from this video to your next Pentominous challenge. We'll see you again soon.